Hi, everybody. This is Miss Wade here. We're going to be talking about a special type of exponential function with a base, with a variable called e. So that's what we're focusing on today. And so e is a famous irrational number, and it is about 2.71828. So we're going to use our calculator to evaluate some of these problems here. So e to the fourth, the E button is right above ln. So we do second ln and see how it has the E with the flashing exponent. So then I put 4. So this gives me about 54.598, etc. So we're going to just do a few more of these. Why don't you guys put them into your calculator and see if you get them right. It's just basically putting stuff into your calculator. Not that difficult. If I want to do a negative exponent, I put that in there and I get 0.135, etc., etc. So when you put these in, it's the answers that you get. So please make sure you know how to use your calculator. Now, when we do exponential functions, when we graph them, we make a table. So for these, y equals e to the x is going to be our parent function. Okay, so that is what we're going to be starting with. Just like exponentials, we start with our parent function and then we apply all the translations. So for this one, we're going to plug in a negative 1, 0, and 1, just like we did before for exponential functions. So I'm going to do e to the negative 1, which gives me approximately 0.367, whatever. So about 0.4. And then anything to the 0 power is 1. And e to the 1 is just 2.7, whatever. So when we graph this, just like before, because it's an exponential function, it has a horizontal asymptote of y equals 0. Okay, and then we just graph the points. So at negative 1, I'm at about 0.37. You're just going to eyeball it. 0, 1, and 1, 2.7. So it's just like the exponential functions that we did before, but it grows a little differently because the base of it is 2.71 instead of just a whole number. So no big deal. So with all of these, we start with our parent function. I'm going to go over this one with you. So it's the same parent function for each one of these. So you can just copy it down. You can round that to 0.4 if you want. Doesn't really matter. Now for this, whenever there's a number outside of the function like this is a negative 1, it means that you multiply y values by negative 1. So I'm going to take each of these and I'm going to multiply by negative 1. So my new table for my translated function, the x's stay the same, and the y's I just multiply by negative. So negative 0.37, negative 1, and negative 2.7. Now my asymptote, because I didn't move up or down, it stays exactly the same. It's still at 0. So there's our horizontal asymptote of y equals 0. And this time it's a reflection. So the graph is going to be down here in quadrants 3 and 4. So negative 1, negative 0.37, 0, negative 1, and 1, negative 2.7. So it's essentially the same graph, just reflected. Okay, now this one moves to the right. So it means you add 1 to the x values. I'm not going to do that one. You can look at the answer key later because we're trying to make these videos a little bit shorter. Let's go ahead and do one that has more than one thing going on so we can apply all of it. So I'm going to do this one here. So it's the same parent function. We always start with that, and then we'll apply all the shifting. So negative 1, 0, 1, 0.37 or 0.4, doesn't matter. Okay, so now let's look at what's happening. Over here, because this goes to the left 2, it means I minus 2 from the x's. Okay, so I'm going to do minus 2, minus 2, minus 2. And then over here, So this shouldn't be too bad because it's exactly the same as the exponential functions we did. This goes down 3, which means you minus 3 from the y's, minus 3, minus 3, minus 3. And because it goes down 3, our asymptote moves down 3. So 1, 2, 3. So there's our new horizontal asymptote of y equals negative 3. And now let's write our new table for the translated values. So negative 1 minus 2 is a negative 3, 0 minus 2 is a negative 2, and 1 minus 2 is a negative 1. And then over here, use my calculator, 0.37 minus 3, oh my gosh, decimals. 0.37 minus 3, don't you hate when you do that? Push the button on the calculator wrong. So negative 2.6, and then 1 minus 3, didn't need my calculator for that one. And then 2.7 minus 3 is negative 0.3. Okay, so I'm going to graph these points. So 1, 2, 3, down 2.6, approximately there, 2, 2, and then negative 1, negative 0.3. It'd be nice if you wanted to find the y-intercept to make this a little cleaner, but whatever. I'm just going to skip that for now. And then this is the same idea. I'm going to go ahead and go to this one because they're all the same, and you can do the other ones on your own for practice. So I'm going to start with the parent function. So negative 1, 0, and 1, 0.37, 1, and 2.7. So now let's look at what's happening. So over here, I have a number on the outside. That is what you multiply the y values by. Okay? So you multiply y by that value. Okay? And then over here, this minus 3 means it goes to the right 3. So I'm going to add 3 to the x's. So plus 3, plus 3, plus 3. And then this right here is up 1. So I'm going to plus 1 to the y's. So plus 1, plus 1, plus 1. Now, when you have multiplication and some kind of addition or subtraction, you always want to do the multiplication first. So my shifted function table, negative 1 plus 3 is 2. And then 0 plus 3 is 3, and 3 plus 1 is 4. And then over here, I'm going to just get my calculator, 0.37 times a negative 2 is negative 0.74. And then when I add 1, I get 0.26. Okay, and then over here, same thing. 1 times negative 2 plus 1 is a negative 1, and 2.7 times 2 plus 1, 2.7 times negative 2 plus 1 is negative 4.4. Okay, so my asymptote, because it goes up 1, is right here. And then I graph my points. So 2.26, 3, negative 1, and 1, 2, 3, 4, 1, 2, 3, 4.4. So there it is. It's a reflection. It goes to the right 3 and then goes up 1. There it is. All right.